We okay?
Yeah, I dropped my
All right, and we're back. Let's do a subscriber count check. Let's see. Still at 91.
What would you do if it just went down like 7?
I'd say, oh well. All right. So again, we're looking at section 4.5. If you looked at my agenda earlier in the week and said we were going to do section 4.4 day 2, that's when I didn't think we were going to get through all the notes yesterday. And then we did. It was perfect. So now we're going to do section 4.5, which means that we get an extra review day before the test, which is always going to be beneficial. So tomorrow I'm going to be giving you the practice test, and I'm going to allow you to work on the practice test in class tomorrow. And then Thursday we'll go over it, and then Friday we'll have our chapter 4 test. Does that sound all right? And then remember, everything this week is going to be on the second 9 weeks. Right? Everything this week is going to be on the second 9 weeks. All right, scatter plots and trend lines. Like we were having a discussion a second ago, this, in my opinion, is one of the most real-life applicable things that we do this year. Because, in section 4.5, we look at, okay, we've done all this graphing stuff with very abstract, hypothetical things like, okay, what if the equation was like x squared plus 2? But what types of things come out to have an equation x squared plus 2? Or, what we're going to look at today is real-life data. And how do we match real-life data with these equations, right? How do we match real-life data? How do we make these equations fit to real-life data? Because if you can make an equation fit to real-life data, what you can do is predict the future. You can predict what's going to happen in the future if that pattern continues. If that trend continues, if that line continues, what's going to happen in the future? And how long is it going to take for that to happen? Again, like we said, companies will pay you big money if you can predict the future and if you're correctly predicting the future. So, scatter plots and trend lines. In this chapter, we've examined relationships between sets of ordered pairs. Displaying data visually can help you see relationships, can help you see trends. Forgive me, I hope we don't need to go over what a scatter plot is. We all know what a scatter plot is? It's just plotting points on a graph and seeing the trend. Scatter plot is a graph with plotted points to show a possible relationship. Okay. Now, what we do need to talk about is this thing called correlation. Correlation. You don't have the definition on there, but it's very important here. Correlation. A correlation describes the relationship between the two data sets. Okay, correlation. Please understand there's a big difference between the word correlate and cause. Like, for example, if you study, you will get a better grade. If you study, you will get a better grade. Or I should say this. If you studying and grades, I guess I should just equate those two things. Would you all agree with me that in general terms, the more you study, the better grades you get? In general. Yes, because those things correlate. Now, if you study, will you get better grades? Like, does that automatically happen? It doesn't always happen, right? There are weird things that happen. Maybe you studied the wrong thing that was going to be on that test or whatever. I don't know. Maybe the test was completely different from what you studied. I don't know. That's causing, right? There's a difference between cause and correlate. You can say that those things will trend to happen together. They tend to happen together. The tendency is that they go with each other. They're tied with each other. However, it does not mean that one makes the other happen. There could be outside factors that also go into it. Okay? So there's a difference between the word correlate and the word cause. Oh no, my wife is calling me on my cell phone. Hold on. And this is on video too. Hi.
Will be a short intermission.
Yes. I can confirm that fact, and I asked her to calculate which one was the better buy. So there you go. That's right. I can confirm that as well, and that was a very big box of kitty litter. Yep. All right. Goodbye, thank you. That was my wife calling me from her classroom, because yesterday, she taught, like, calculating a better buy, like, which is the better unit rate, like pounds per price or whatever.
Yeah.
She taught that yesterday, and then she was in Target, and she was figuring out which kitty litter to buy, because there were two different sizes, so she had to calculate which one was the better buy. No, she got the right one. She's a math teacher, so I would hope so. So there's math in real life there. That's different than what we're, I know. All right. All right. Okay, so there are different types of correlation. There is positive correlation, quiet please. There's positive correlation, there's negative correlation, and there's no correlation at all. The positive correlation is when both data values will increase at the same time. As I increase the amount of studying, my grade increases as well. Negative correlation is something where if I increase something, something else will decrease. Like, for example, think about the temperature in the month of October, okay? As I increase my days in October, what happens to the temperature? Generally going down, right? Again, we're talking about tendencies. We're talking about trends. It tends to go downward. So as I increase my x values, my y values tend to decrease. That would be a negative correlation. And then no correlation at all. Get out of there. There's no relationship between the data sets. Something that we have to add in here is talking about the R values. Talking about the R values. The pirate's favorite mathematical term. The R value. The R value. Please add this into your guided notes. The R value. That's the strength of the correlation. Strength of correlation. Okay? It can range from -1 to +1. Okay? It can range from -1 to +1. Over on the -1 side, that is considered a strong correlation, strongest you could possibly get, but in a negative direction. So a negative sloping line. As you get closer to 0, it gets weaker. Okay? On the positive side, that's a strong correlation over here, but in the positive direction. And as you continue to get closer to 0, it gets weaker. And at 0, there is no correlation. So there are going to be some problems on tonight's homework where I'm going to ask you to estimate the R values. Estimate the R values. Now, when you get to Algebra 2, you're going to actually find out how you calculate it. But for right now, we're just going to estimate it. Like, for example, this first one here. Let's estimate the R values here. You see how I see a pretty strong correlation in the positive direction, right? So I know my R value is going to be positive, and it's going to be somewhat close to 1. Let's say the R value is about, that squiggly equal sign means about, my R value is about 0.9. Okay? If it was 1, those dots would be exactly on that line. So if I say this is about positive 0.9, what do you think the R value is about on that one? Like negative 0.9. Yeah, negative. It's a negative sloping line. They're pretty close together. Negative 0.9. Negative 0.8, negative 0.9, somewhere in there. The more the data spreads out away from that line, the closer to 0. So what would we say the R value would be around here? 0.
Where are you getting the 0.9 from?
I'm estimating.
Okay, yeah, but what are you estimating?
Okay, do you see how it's close to that line?
Yeah.
So therefore, if it's closer to that line, if it's a strong correlation, right? It's closer to that line, then I know that it's going to be closer to either positive 1 or negative 1.
What if it was just all in a straight line?
Then it's exactly at 1.
So the closer it is to the line, the higher the decimal is.
Exactly. Yes, and that's the key to the R value. The closer it is to that line, the stronger the correlation. The stronger the correlation, the closer it gets to either 1 or negative 1. The positive or negative really just means the slope. Up and to the right is a positive slope, down and to the right is a negative slope. All right, so let's take a look here. The table shows the number of cookies in a jar from time since they were baked. Let's graph the scatter plots. Okay, so go ahead and plot these points with me on your graph as well. Notice that my axes are labeled. Perfect. So we have 1, 24, 2, 16. Oh, that's right on the dot there. Yeah, right there. 3, 10, and 4, 7. What type of correlation are we seeing here? A negative correlation. A negative correlation. Negative correlation. You know, I don't think we have enough data to plot a trend line, you know, but does it exactly match? No, so we would say probably again like a negative 0.9, something like that, negative 0.95, I don't know. We're just estimating there. Something strong but in the negative direction. Take a look here. Let's identify the number of the type of correlation that we would expect to see. The number of members in a family and the size of that family's grocery bill. Joey? Positive correlation. As I increase the amount of family members, does the grocery bill increase or decrease? Increase. So as I increase my x's, my y's go up as well. That is a positive correlation. The number of times you sharpen your pencil and the length of your pencil. What would that be? Negative correlation. Negative correlation.
We just label these pods and like.
Sure.
So if you're gonna have to graph a lot.
No, not too much. Just maybe 1, 2 problems, maybe. The size of your foot and your grade in algebra. Really? So as I increase the size of my foot, the algebra grade will go
No,
down.
it just keeps going down.
It just keeps going down. Oh, okay. See, you never know. Who knows? Maybe there is some sort of correlation. Maybe one of you will go on to do a study about the size of your feet and students' algebra grades. You never know. But I'm going to say right now there's no correlation. Yeah. And again, understand the difference between correlation and causation, right? Let's take a look here. Choose the scatter plot that best represents the relationship. Okay, so the relationship that I'm trying to show is the money spent on the car and the age of the car. What do we expect to happen as my car increases with age? What should happen on the money spent? It should increase. If the car is 10 years old, you're going to spend more on repairs on it?
Oh.
Probably, right? So as the car's age increases, the price of repairs is probably going to increase. So which graph can we throw out right away?
A.
Well,
Because you can't even.
I'm going to say C because we talked about it's not going to be a negative correlation, it's going to be a positive correlation. Now I see a positive correlation in both A and B, but what's wrong with A? Well,
You can't have a car that's negative 40.
right, that doesn't make sense. So let's throw out A. My only possible solution would be graph B. What would you estimate the R value to be? 0.8. 0.8, 0.7, 0.8, you know, whatever in there. 0.832. Here's what I would accept any of those numbers, right? But here's what I would not accept. anything below 0.5, because obviously I see some sort of correlation, right? And definitely don't put a negative because it's a positive correlation. We've already been talking about it, but we can look also at a trend line. The trend line is just a line of best fit. It basically goes through the data, and it allows us to make predictions. Yes.
If we're doing trends, then how would there be a negative? There isn't really a negative.
Negative correlation. As one thing goes up, the other thing goes down.
Yeah,
Like,
I see what you're saying, but you can't now if it's on a card, we can't go in the negative card.
no. Here's what I'm saying. As the car, like, think about this. Is there a correlation between the age of the car and its price? Right? That's a negative correlation. It's not negative values. It's just a negative correlation. As my X values increase, as the age of the car increases, the sale price is going to go downward. That's what I mean by a negative correlation. It's not going to go into the negative numbers.
Definitely.
Right. It's not going to be, if negative correlation does not mean negative numbers. Negative correlation just means those things are trending downward, not trending upward. Make sense?
Yeah.
Okay. So take a look here. The scatter plot shows the number of orders placed for flowers before Valentine's Day at one shop. Based on this relationship, draw the line of best fit and predict the number of flower orders placed on February 12th. So right now, go ahead and draw in a straight line that runs through most of those points. Do that for yourself. Make it extend all the way through your graph. Draw your trend line.
From 0?
Well, no, go from through the points. Like here in mine, I'm going to use my straight line tool. Okay, that looks pretty good to me. It goes through most of my points.
I'm pretty sure it actually goes through all of them.
Now, what would we say about my R value?
0.99.
0.99. It's very close to 1, right? It's not close at all to -1, right? It's not -1. Positive 1, positive correlation. Okay, it says on February 12th. So everybody right now, find February 12th and make a dotted line up to your line. And now make it go over and figure out your Y value. 5, 10, 15, 20, 30, 40. It's like, for me, it's around 40, maybe 43.
What would you accept it?
Anything, honestly, from 40 to 50, or 40, really 40 to 45. Because obviously the graph is going to stop at 45. Okay, and what did we do here? We predicted the future. We said, based on this trend, like maybe I'm the owner of this shop, and I want to know how many flowers to buy. If I want to know how many flowers to buy, maybe I can plot the points, graph the trend, and see where it's going to end up. That's going to tell me how many flowers to buy. All right, time flies when you're having fun. It's about 10. So long, everybody.